Now we'll start the new chapter, limits. In this chapter, we will learn meaning, definition of limit, calculation of various limits, limits of trigonometric functions, limits of exponential and limits of logarithmic functions, limit at infinity and infinite limit. From this chapter, all the chapters are very important. Limits, differentiation, continuity. All these chapters are important if you are going to engineering or BSc in mathematics and the MSc mathematics. This is the calculus part. The calculus is an important branch of the mathematics. The concept of limit of a function is a fundamental concept in calculus. Now, this is the introduction. Calculus is an important branch of mathematics. The concept of limit of a function is a fundamental concept in calculus. Now we'll see the definition of limit. Before that, we will see the one concept. What is that concept? A limit of a function. Suppose x is a variable and a is a constant, and if x takes the values closer and closer to a but not equal to a, then we say that x tends to a. That is, x is not equal to a, but x tends to nearer to a. This is the concept of the limit. And symbolically, it is denoted as x tends to a. Now we'll see the definition. If given epsilon, now what is meant by the epsilon? Epsilon is a number which is positive. There exists delta greater than 0 such that mod of f of x minus l less than epsilon for all mod of x minus a less than delta. Then we say that f of x tends to L as x tends to a, x tends to 0, x tends to a here. By mistake it is written. Now we'll again see here. It is treated as a, x tends to a, f of x is equals to L. Now note the some important results. What is the first result? The first result is limit of x as x tends to a is equals to a. How to read this? Limit of x. What is your function? The function is x. This type of function x is called the algebraic function. X tends to a. Limit of x as x tends to a is equals to a. What we have done here, x is replaced by a. Now, next. Now the next is, that is the limit. See this here again. Next formula is limit x tends to a of the function k, or the limit of k as x tends to a is equals to k. That is the limit of constant is always constant. For example, limit x tends to 5, x tends to a, and suppose in the place of the k, if we take 5, then answer is 5. That is the limit of 10 as x tends to a. That is answer is 10. That is the limit of constant is constant. Now next. Now again see this formula. Limit x tends to a of x raised to n, or the limit of x raised to n as x tends to a is equals to a raised to n. What we are doing here? We replace here x by a, and therefore the answer is a raised to n. Next, limit rth root of x as x tends to a is equals to rth root of a. That is again here we are replacing x as a. That is a limit rth root of x as x tends to a is equals to rth root of a. If p of x is a polynomial, then the limit x tends to a of p of x is equals to p of a. Limit p of x, limit of p of x as x tends to a is equals to p of a. It means that here we replace x by a. x की जगह पर हम क्या लिख रहे हैं? a लिख रहे हैं. Next. This is important formula. Again, see this here. Limit of x raised to n minus a raised to n upon x minus a as x tends to a is equals to n into a raised to n minus 1. Now here we replace that is the x by a. I will again repeat, limit x tends to a x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1, where n belongs to set of natural number and a is a positive rational number. Now next. That is, instead of this x, we treat as a, it's a small mistake maybe. If n is less than 0, say n is equals to minus n, then limit x tends to a, x raised to n minus a raised to n upon x minus a is equals to, now again you can see here, that is a limit x tends to a x raised to n minus a raised to n upon x minus a. Then limit x tends to a. That is, we replace here. Suppose it is a negative. Then what will happen? The same thing is here. Whatever that the power, that will comes to the first and 1 will be the radius from that power. Now we'll see the examples depending. Simple type of the examples. In this example, we replace x by whatever that limit tends to. Now the exercise 7.1. Evaluate the following limits. That is, limit z tends to minus 3, z plus 6 upon z. Now see this here, limit z tends to minus 3. What is the function? In root of z plus 6 upon z. Here we replace by z by minus 3. That is minus 3 plus 6. Then we are getting the 3, root 3 upon 3. Root 3 upon 3. That is nothing but 1 upon root. Now this is very simple limit. In this limit, we replace z by minus 3 and find out the answer of this limit. Now see this here. Now how to write all these steps? Let L is equals to, every time we write L is equals to limit z tends to minus 3 in root of z plus 6 upon z. Now in this step, we will take the direct limit here. That is in root of minus 3 plus 6 upon minus 3. Minus 3 and plus 6 is 3. That is the root of 3 upon minus 3. And this is equals to minus 1 upon root 3. Therefore, the limit of in root of, therefore L is equals to limit of in root of z plus 6 upon z, where z tends to minus 3 is equals to minus 1 upon root 3. Now the second problem, y tends to minus 3 of function is y raised to 5 plus 243 upon y raised to 3 plus 27. Now if we substitute here y is equals to minus 3 direct, if we take the direct limit, then we will get the indeterminate form, that is 0 upon 0. For example, if we substitute here y is equals to minus 3, that is minus 3 raised to 5, then the answer is minus 243. Minus 243 plus 243 will become 0 numerator, and for the denominator it will become minus 27 plus 27. That is 0 upon 0. It is indeterminate form. Therefore, we try to avoid this form. Then what to do here? That is, we make here the adjustment like this. Divide numerator and denominator by y plus 3 first of all. See this here. Divide n and d by y plus 3. That is, we are applying the formula as a limit x tends to a, x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1. Now see this here. Now how I had written, I will explain now. Now see this here. That is a y raised to, again I will show you. In case of the numerator, that is y raised to 5 minus in bracket minus 3 bracket raised to 5. Minus 3 bracket raised to 5. It becomes minus 243. And minus minus will become plus. That is a plus 243. That is where here we adjust. That is a minus sign. But the meaning doesn't change here. That is a y raised to 5 plus 243. Y raised to 5 plus 243 upon y minus in bracket minus 3. Again y plus 3. If we simplify this, then you are getting like this. Because we are tending to bring that in that form. That's what is the form that we require here. For the denominator also, here we write divided by, now see this here, that is y cube minus in bracket minus 3 bracket raised to 3. You will say that why we are doing like this. That is, we get the 0 upon 0 form, which is indeterminate form. To avoid this form, we apply the formula, that is a x raised to n minus a raised to n upon x minus a. As x tends to a, we will get n into a raised to n minus 1. Therefore, if you apply the formula, then you will get now here we will apply the formula, that is 5 into in bracket minus 3 bracket raised to 5 minus 1 whole divided by 3 in bracket minus 3 3 raised to minus 3 raised to 3 minus 1. Now see this here, we are applying the formula and writing here that formula. This is the formula. And now we will evaluate this, that is a 5 minus 1, that is a minus 3 raised to 4, 3 minus 3 raised to 2. Therefore, you will get minus 3 raised to 4, that is 81, and here denominator you will get the 9. And instead of that, we are applying here the law of indices. That is minus 3 raised to 4 minus 2, then minus 3 raised to 2. And hence, this is the final answer. That is the, you can see again, this is the answer. It's very simple one. Therefore, the answer is L is equals to 15. Now we'll see the next problem. That is the problem number 3. Limit z tends to minus 5 and the function is 1 upon z plus 1 upon 5 upon z plus 5. Now, if we see this here, if we take the direct limit, that is z is equals to minus 5, then you get the denominator as 0, which is indeterminate form. Therefore, to avoid the indeterminate form, we simplify this like this. That we take the cross multiplication first of all. That is here is a cross multiplication. That is 5 plus z upon 5z upon z plus 5. And now what will happen? Z plus 5 upon z plus 5 into 1 upon 5z. Z plus 5, z plus 5 get cancelled. Now replace z by minus 5. Therefore you will get, that is a minus 1 upon 25. Therefore, L is equals to minus 1 upon 25. This is the answer. Now next, question number 2. Evaluate the following limits. N is equals to limit x tends to 3 in root of 2x plus 6 upon x. Now what is happening here? Now here if we substitute x is equals to 3, then 2 into 3, that is a 6. 6 plus 6, 12. That is in root of 12 upon 3. And then we do not have any problem here. We do not get indeterminate form. Therefore, here we directly now in this case we substitute direct x is equals to 3 because we are not getting indeterminate form. Now see this here. That is a 2 into 3 in root of 2 into 3 plus 6. That is 6 plus 6, 12. These are the steps. You can see this here. You can also write if you want to write these steps. That is 4 into 3 upon this. And the root of the 4 is equals to 2. That is a 2 into root 3 upon 3. That is a 2 upon root 3. This is the final answer. Or you may write like this. These are the two types of answers. Now next also you can see if you want to see again. Next, question number 2. Evaluate the following limits. That is the same problem is repeating here. Therefore, the same is repeated here. Now let's see the next problem. Limit x tends to 2, x raised to minus 3, minus 2 raised to minus 3 upon x minus 2. Now here we will apply the formula. One thing is remain to that. Remember that whatever the power here, we apply the same formula. We get the correct result. If the index is minus or plus or the fraction, apply that same formula here. Now what is the limit x tends to 2, x raised to minus 3, minus 2 raised to minus 3 upon x minus 2. Therefore minus 3 into 2 raised to minus 3 minus 1. This is the basic formula. That is the limit x tends to a, x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1. Therefore, you can see this here, minus 3 minus 1. That is 2 raised to minus 4. Therefore, minus 3 upon 2 raised to 4. And what is the value of 2 raised to 4? The value of 2 raised to 4 is 16. Therefore, this is the answer. Now you can see this also. These are the small. Next, problem number 3. Now see this here problem. That is the limit x tends to 5. X raised to 3 minus 125 upon x raised to 5 upon x raised to 5 minus 3125. Now here is a 125 means what? 5 raised to 3. And 3125 means what? 5 raised to 5. Therefore, as limit x tends to 5, x raised to 3 minus 5 raised to 3. Now, upon x raised to 5 minus 5 raised to 5. Now, divide numerator and the denominator by x minus 5. Therefore, you will get, this is the numerator and to the denominator, it is like this. That is the divide n and d by x minus 5. Now the next is limit x tends to, then we will apply the formula. What is the formula? This power comes here into 3 raised to 5 raised to 3 minus 1 upon 5 into 5 raised to 5 minus 1. That is a 3 by 5. 5 raised to 2 upon 5 raised to 4. Therefore, you will get that is here is a 3 as it is 5 raised to 2. Now here is 5 raised to 1 and 5 raised to 4. Then you get 5 raised to 5. Therefore, 3 into 1 upon 5 raised to 3. And 1 upon 5 raised to 3 is 3 upon 125. Therefore, here L is equals to 3 upon 125. Next, if limit x tends to 1, x raised to 4 minus 1, this is the problem, x tends to 1, x raised to 4 minus 1 upon x minus 1. That is here 1, this one will treat as 1 raised to 4. If you take 1 raised to 4, 1 raised to 5, it will give the same value. Now in this problem, we have x raised to 4. Therefore, we here write 1 raised to 4. See this here again here. That is the limit. This is equals to limit x tends to a. X raised to 3 minus a raised to 3 upon x minus a. Now what will the answer here? That is a 3 into a raised to 3 minus 1. And what will the answer here? 4 into 1 raised to 4 minus 1. Therefore, that is equals to here. That is we can write like this. This we can write. That is it. Again, you can see this. Now we'll apply the formula here. That is it. 4 into, this is the formula. That is 4 into 1 raised to 4 minus 1 and to the again right hand 3 into a raised to 3 minus 1. Therefore, 4 into 1 raised to 4 minus 1, that is 1, and equals to 3 into a raised to 3 minus 1 means what? A square. Therefore, that is a 4 upon 3 is equals to a square. Therefore, a is equals to plus or minus 2 upon root 3. This is the answer. Taking the square root. The square root of 4 is 2 and 3. That is a plus or minus root 3. Now the next is question number 3. Evaluate the following limits. First is limit x tends to 1, x plus x square plus x cube plus dash dash plus x raised to n minus n upon x minus 1. Now what's happening here? Here's a minus n. Meaning of the minus n means what? 1 into n. Means what? This 1 is repeated n times. And all these numbers are minus. And we take this minus number for each of these x. That is, it is x minus 1 plus x square minus 1 plus x cube minus 1 plus dash dash x raised to n minus 1 upon x minus 1. That is the limit. L is equals to limit x tends to 1. And we write it like this, 1 into n upon x minus 1. This is an important step to understand for all of you. That is, n means what? 1 into n. That is, 1 is repeated n times. That is x minus 1 plus x square minus 1 plus x cube minus 1 x raised to n minus 1 and this whole divided by x minus 1. Now split up this. Then how to split up this? That is x minus 1 upon x minus 1 plus x square minus 1 upon x minus 1 plus x cube minus 1 upon x minus 1 plus dash dash plus x raised to n minus 1 upon x minus 1. Now we can write it like this. Split up this means what? X minus 1 upon x minus 1 plus x square minus 1 upon x minus 1 plus x cube minus 1 upon x minus 1 and in this way. And now we will apply the formula. But this is very simple, that x minus 1 upon x minus 1. That is, we will apply the formula, or numerator and denominator both are the same. The answer is 1. Therefore, here directly we apply the formula. The first answer is 1. What about the second? Now here, see this. That is x square minus 1. Means what? 1 means what? 1 square. That is x square minus 1 square upon x minus 1. Therefore, you will get 2 into 1 raised to 2 minus 1 plus 3 into 1 raised to 3 minus 1 plus dash dash. And what about the last term? That x raised to n minus 1 raised to n upon x minus 1. That is nothing but the n into 1 raised to n minus 1. And the value of the 1 raised to n minus 1 is again 1 here. Now, therefore, you can see this here. This is important. The answer of this x raised to n minus 1 upon x minus 1 is n in n dot 1 raised to n minus 1. Therefore, you will get in bracket, this is the 1, 2 into 1, 3 into 1 plus dash dash up to the n. Now, if you see this, the terms are like this: 1 plus 2 plus 3 plus dash dash plus n. This is the arithmetic progression. Here a is equals to 1, d is equals to 1, and we can calculate here its value. Therefore, a is equals to 1, d is equals to 1. Therefore, sum is equals to n upon 2 in bracket 2a plus n minus 1 into d. That is 1 upon n upon 2. A means what? The a is equals to 1. 2 into 1 plus n minus 1 into d. d is 1 and we can calculate. That is 2 plus n minus 1. And therefore, we are getting the answer n upon 2 into n plus 1. This is the answer. That is the sum is equals to n into n plus 1 upon 2. This is the answer, and hence L is equals to n into n plus 1 upon 2. The next is number 2. Limit x tends to 7. That is cubic root of x minus cubic root of 7 into cubic root of x plus cubic root of 7 upon x minus 7. Now see the second problem. This is the problem. Now what is happening here? Here is a minus b into a plus b. It means that a square minus b square. That is cubic root of x is written as x raised to 1 upon 3 bracket raised to 2 minus 7 raised to 1 upon 3 bracket square upon x minus 7. This is, that is a minus b into a plus b. That is cubic root of x bracket square minus cubic root of 7 bracket square. Next problem, question number 2. Limit x tends to 7. Cubic in bracket cubic root of x minus cubic root of 7 in second bracket cubic root of x plus cubic root of 7 bracket complete upon x minus 7. Now we'll solve this example. Now you see this here, a minus b into a plus b. Then you will get a square minus b square, and then we will solve this example. Now see this. That is, we write here cubic root of x bracket square minus cubic root of 7 bracket square upon x minus 7. A minus b into a plus b. Cubic root of x bracket square minus cubic root of 7 bracket square upon x minus 7. Limit x tends to 7, and it can be written as now, that is x raised to 2 by 3 minus 7 raised to 2 by 3 upon x minus 7. Now here we will apply the formula. That is a 2 by 3, 7 raised to 2 by 3 minus 1. That is a 7 raised to 2 by 3 means what? Minus 1 upon 3. And therefore the answer is 2 by 3 into 7 raised to minus 1 upon 3. That is, we can make its sign as a positive. Therefore the next is 2 upon 3. That is the cubic root of 7, and this is the answer. Now see this. This is the final answer. That is the 2 upon 3 into 1 upon cubic root of 7. Now we'll see the next example. Example number 3. If limit x tends to 5, x raised to k minus 5 raised to k upon x minus 5 is equals to 5000. Find all possible values of k. Therefore, now here we will apply the formula, that is equals to 500 to the left hand side, and that is equals to k into 5 raised to k minus 1 is equals to 500. That is equals to 5 into, that is a, here is a k into 5 raised to k minus 1 is equals to 500. This 500 can be written as 4 into 125. Now here 125 means what? 5 raised to 3. And 5 raised to 3 can be written as 5 raised to 4 minus 1. Therefore, by the observation, we will get the value of k. The value of k is equals to 4. K is equals to 4. This is the answer. K is equals to 4. If we observe this, therefore k into 5 raised to k minus 1 is equals to 4 into 5 raised to 4 minus 1. Therefore k is equals to 4. Now next example. Limit x tends to 0, 1 minus x bracket raised to 8 minus 1 upon 1 minus x bracket square minus 1 as x tends to 0. Now where x tends to 0 and we have 1 minus x. To solve this type of the example, suppose that if we substitute x is equals to 0, then what you will get? That is 1 raised to 8 means what? 1. 1 minus 1, 0. And denominator also 1 minus 1, that will also become 0. That's we are getting the indeterminate form. Therefore, to avoid this, we can make the substitution, and the substitution will be like this. Here put y is equals to 1 minus x. Now how we select this substitution? That is whatever that here 1 minus x. That is put y is equals to 1 minus x. Now what is about x? X tends to 0. Means what? Here substitute x is equals to 0. Then what you will get? Y is equals to 1. Therefore, whenever that x tends to 0, y tends to 1. Therefore, our limit becomes y is equals to 1. This is very important. That is the limit x tends to 0, 1 minus x bracket raised to 8 minus 1 upon 1 minus x bracket square minus 1. Limit y tends to 0. Now this step is important. That is we have substituted, that is y is equals to 1 minus x. Y is equals to 1 minus x. 1 minus x bracket raised to 8. Therefore here is y raised to 8 minus 1. To the denominator there is also 1 minus x bracket raised to 2. Therefore here is a y square minus 1. But again, as we are changing the variable, means what? Here is x, everywhere is x, and here is a y. That is we are changing the variable here. When we change the variable, at the same time we also change the limit. What is the limit here? The limit is x tends to 0. Therefore, as x tends to 0, means what? In this equation, we will substitute here x is equals to 0. Therefore, as x is equals to 0, then you will get y is equals to 1. That is, we say that y tends to 1. Therefore, whenever that as x tends to 0, y tends to 1. When we replace here x by y, at the same time, we also change the limit of that function. Now, the next is, now in this case, we will divide the numerator and the denominator by y minus 1. Y raised to 8 minus 1. Divide n and d by y minus 1. Therefore, limit y tends to 1. Y raised to 8 minus 1 upon y minus 1 upon y square minus 1 upon y minus 1. And that's why you will get y tends to 1, y raised to 8 minus 1. Now, this is the important step. That is y raised to 8 minus 1 raised to 8. 1 raised to 8 is overall its value is 1. For the adjustment, we are making this divided by y minus 1. To the denominator, y square minus 1 square upon y minus 1. Now here we will apply the formula. That is 8 into 1 raised to 8 minus 1 upon 2 into 1 raised to 2 minus 1. And that's why we will get the answer 8 into 1 raised to 8 minus 1. This is 8 into 1 raised to 8 minus 1 upon 2 into 1 raised to 2 minus 1. Therefore, here is 1 raised to 8 minus 1 means what? 1. 1 raised to 2 minus 1 is again 1. 8 upon 2, and that is equals to 4. Therefore, the answer is, the final answer is L is equals to 4. Now the next is question number 5. Limit x tends to 0 in cubic root of 1 plus x minus root of 1 plus x upon x. Now this is the example. Cubic root of 1 plus x minus square root of 1 plus x upon x. If we substitute x is equals to 0, then what you will get? Cubic root of 1 means 1. Here is a square root of 1 is 1. 1 minus 1 is 0. 0 upon 0, it's a indeterminate form. Therefore, again, we have to make here substitutions. And that's why we will solve our limit. Put here 1 plus x is equals to y. This is our substitution. Then you will say that how we are taking this substitution. Whatever here, that is, we will take that substitution. That is 1 plus x is equals to y. As x tends to 0, then y tends to 1. That is, put here x is equals to 0. Therefore, y tends to 1. Now, see this here. Therefore, now you can see this also. Yeah. Square root of y upon y minus 1. Now here, that is a cubic root of y minus square root of y upon y minus 1. Again, we want our regular format. What is that? X raised to n minus a raised to n upon x minus a. These are our formulas. Therefore, we'll write here. That is the limit y tends to 1. Y raised to 1 upon 3 minus y raised to 1 upon 2 upon y minus 1. Therefore, limit as y tends to 1. And now here, we'll require plus 1 and minus 1. Using that, we can balance it. Now, see this here. Y raised to 1 upon 3, we require minus 1. Here's a minus y raised to 1 upon 2. To balance this minus 1, we add here plus 1. Therefore, now see this here. Now see this here. Y raised to 1 upon 3 minus 1. We are taking the minus sign as common. Then you will get y raised to 1 upon 2 minus 1 upon y minus 1. Now split up this means what? We will divide. That is y raised to 1 upon 3 minus 1 upon y minus 1 minus y raised to 1 upon 2 minus 1 upon y minus 1. And therefore, you will get limit y tends to 1, y raised to 1 upon 3 minus 1 upon y minus 1 and y raised to 1 upon 2 minus 1 upon y minus 1. And that's why you will get y minus 1. This is important. Now we'll apply the formula here. That is, you will get that is 1 upon 3. That is y raised to, that is 1 upon 3 into 1 raised to 1 upon 3 minus 1 minus 1 upon 2 into 1 raised to 1 upon 2 minus 1. 1 raised to any number, the value is again 1. minus 1 upon 2 dot 1. That is 1 by 3 minus 1 upon 2. Now we will solve by using the cross multiplication. That is a 2 minus 3 upon 6 minus 1 upon 6. And hence the value of limit is minus 1 upon 6. Therefore, the answer is 1 upon 6. Now next example. Limit y tends to 1, 2y minus 2 upon cubic root of 7 plus y minus 2. Now to solve this example, that is a limit y tends to 1. Take 2 as common, then you will get y plus 7 raised to 1 upon 3 minus 2. Therefore, we can write like this. Now, what is our substitutions here? Y plus 7 raised to 1 upon 3, and here is 2 means 8 raised to 1 upon 3 upon y minus 1. That is a 2 upon y plus 7 raised to 1 upon 3 minus 8 raised to 1 upon 3. Now here y minus 1 can be written as, that is a 2 upon y plus 7 bracket raised to 1 upon 3 minus 8 raised to 1 upon 3 upon y plus 7 bracket complete minus 8. Therefore here we'll put y plus 7 is equals to x. As x tends to 1, y tends to 8. This is important. That we are changing the variable. Variable is from y to x. Therefore put y plus 7 is equals to x. As x tends, y tends to 1, x tends to 8. Therefore x tends to 8, 2 upon x raised to 1 upon, see this here, that is y plus 7. Here is a y plus 7 means what? X raised to 1 upon 3 minus 8 raised to 1 upon 3 upon x minus 8. And now here we will apply the formula. This here. That is equals to 2 upon 1 upon 3 into 8 raised to 1 by 3 minus 1. Therefore, if we simplify this, 8 means what? 2 raised to 3. Now this 3 get cancelled, and that is a 2 raised to minus 2. That is 2 raised to minus 2. When it comes to the numerator, it becomes now say this here 2 raised to minus 2, and simplify this, then you will get the 24. Therefore, L is equals to 24. Also, you can see the whole problem here. Therefore, L is equals to 24. Now we see the next. Number 7. Limit z tends to a, z plus 2 bracket raised to 3 by 2 minus a plus 2 bracket raised to 3 by 2 upon z minus a. Now this is again an important problem, because here we have the two substitutions. That is, here we take the two substitutions that is a z plus 2 is equals to x, and a plus 2 is equals to b. Now when z tends to a, then you will get a plus 2. See this here is equals to b. Now first of all, when z tends to a, therefore x is equals to z plus a. Therefore you will get x is equals to a plus 2, and therefore that is the x is equals to b a plus 2. But what is a plus 2? A plus 2 is nothing but the b. At z tends to a, z plus 2 tends to a plus 2. But z plus 2 is therefore x tends to b. This is important. As z tends to a, z plus 2 tends to a plus 2. But what is a z plus 2? Z plus 2 is equals to x. Therefore x tends to b. Therefore the limit x tends to b, x raised to 3 by 2 minus b raised to 3 by 2 upon x minus 2 minus in bracket b minus 2. And therefore here we will apply the formula, that is 3 by 2 b raised to 1 upon 2, and therefore the answer is, this is the final answer. You can also see the whole answer how I had written it. And therefore this is the final answer. Now we'll see the next problem. That is problem number 8. Limit x tends to 7, x raised to 3 minus 343 upon root x minus root 7. Now there is a 343 means what? 7 raised to 3. That is limit x tends to 7, x raised to 3 minus 7 raised to 3 upon x raised to 1 upon 2 minus 7 raised to 1 upon 2. Therefore divide numerator and the denominator by x minus 7. Therefore limit x tends to 7, x raised to 3 minus 7 raised to 3 upon x minus 7 upon x raised to 1 upon 2 minus 7 raised to 1 upon 2 upon x minus 7. Now here we will apply the formula, that is equals to 3 into 7 raised to 3 minus 1 upon 1 upon 2 into 7 raised to 1 upon 2. Therefore next is simplification. Normal simplification is there. Now here see that is a 3 upon 1 upon 2, that is a 3 into 2 into 7 raised to 2 minus 1 upon 2, that will become plus, that is a 4 plus 1, that is a 5 by 2. Therefore 6 into 7 raised to 5 upon 2, that is 7 square, that is 6 into 7 square into 7 raised to 1 upon 2, that is a 6 into 49 into 7 raised to 1 upon 2. That is a 294 into 7 raised to 1 upon 2. Therefore, that is equals to limit L is equals to 294 root of 7. This is the final answer. Now the next is problem number 9. L is equals to limit x tends to 1, x plus x cube plus x raised to 5 plus dash plus x raised to 2n minus 1 minus n upon x minus 1. Now here is again, this is the n. N means what? 1 into n. Means 1 is repeated n times. Now that 1 will take for each of these x, x cube, x raised to 5 to this. And we will solve the example. This is the n times. We can write it like this. Minus n means what? 1 plus 1 plus up to the n times upon x minus 1. Therefore, limit x tends to 1, x minus 1. For each x, we will take that 1. That is x minus 1, x cube minus 1, x raised to 5 minus 1. Up to x raised to 2n minus 1 minus 1. And upon whole divided by x minus 1. And here we will apply the formula for each term. That x minus 1 upon x minus 1 plus x cube minus 1 cube upon. That is limit x tends to 1, x minus 1 upon x minus 1 plus x cube minus 1 cube upon x minus 1 plus x raised to 5 minus 1 raised to 5 upon x minus 1 plus dash dash plus x raised to 2n minus 1 minus 1 raised to 2n minus 1 upon x minus 1. And if we apply the formula for each term, then you will get, that is a 1 into 1 raised to 1 minus 1 plus 3 into 1 raised to 3 minus 1 plus 5 into 1 raised to 5 minus 1 plus dash dash plus 2n minus 1 into 1 raised to 2n minus 2. Now see this here. Minus. And the value of each term is, that is first is 1, 3, 5 and last is 2n minus 1. Now here we have learned in the sequence and series, this is the summation of r is equals to 1 to n in bracket 2r minus 1. Now here we will take their summation, that is summation of the r. R is n into n plus 1 upon 2 and the summation of 1 is n. Therefore 2 into n plus 1 upon 2 minus n. Now here these two get cancelled, that is n into n plus 1 minus n. N square plus n minus n, and final answer is n square. Therefore L is equals to n square. This is the final answer. And in this way we have completed the first exercise. Now we'll see in the next video. Till then, goodbye.